The first thing, I gave you the handout on the inverse tangent a couple of days ago. How many of you have that with you? And can I steal one of your copies? Because I forgot to bring mine. Okay, so we are going to go over most of the items in that handout. And these handouts are also your homeworks. Okay, so you should make sure you understand every single items in these handouts. All right, so what we want to do today is inverse tangent first. The inverse tangent function, what are the notations that are used for that? Arctangent of x. Usually people don't write parentheses around x. Tangent with a -1 in the superscript of x. That's also used without the parentheses as well. Both of the second notation is the more confusing notation, because when you see that -1 in the exponent, you think that it is 1 divided by tangent, right? But it's not 1 divided by tangent, okay? Everybody please remember that. Tangent to the -1x is not 1 divided by tangent, okay? It is the inverse of the tangent function, and I'm going to describe what that is in a second. So first of all, what's the graph of the tangent function? The graph of the tangent function is basically, again, the tangent function is a periodic function, right? So it is a periodic function with period pi, in fact. So once you know the graph of tangent between -π/2 and +π/2, you just repeat the pattern. You just repeat the pattern over the entire real line. Now, what's the domain of the tangent function? The domain of the largest domain of the tangent function is what? All real numbers, except you ran out. Okay, whoever didn't get it, I'll just give them later. Okay. What's the domain of the tangent function? It's all real numbers except for what points? I'm sorry? Multiples of π/2, but is it all multiples of π/2? Odd multiples or even multiples? Odd multiples. Except for the odd multiples of π/2, tangent is defined at any real numbers. At any real number. Now, that's the graph of tangent. So obviously, the tangent function being a periodic function, it cannot be 1-to-1. So just like in the case of sine function and the cosine function, what did we do? We restricted the domain of tangent in such a way that we don't lose any of the range values, right? What's the range of the tangent function? What's the range of the tangent function? Yeah, all real numbers. So I want to take a piece which is 1-to-1, but it doesn't lose any of the range values. And such a piece would be -π/2 to +π/2. So I am going to restrict the domain of tangent from -π/2 to +π/2. Of course, excluding -π/2 and +π/2 because they are not in the domain. So now I'm going to concentrate on so here the pink curve is the graph of tangent of x between -π/2 and +π/2. I have the pink curve, that's the graph of tangent. It is 1-to-1 there, so it has an inverse, right? So y equals to tangent inverse of x. What would be the domain of the inverse tangent? What would be the domain of the inverse tangent? Would be the domain of it would be the range of tangent, and the range of tangent is all real numbers. So that's the domain of tangent inverse. What would be the range of tangent? What's the range of tangent? Can someone tell me what's the range of tangent? So yeah, because the range of tangent would be the restricted domain of tangent that we picked to make it one-to-one. Right? So maybe I should write that down. Range of tangent inverse of x is from negative pi over 2 to positive pi over 2. Okay, so that's the range of tangent inverse. It is the inverse of the tangent function, so can I come up with the graph? Well, yes. First of all, look at the graph of tangent. It has a vertical asymptote at negative pi over 2 and a positive pi over 2. Right? Now, because tangent has a vertical asymptote at pi over 2, inverse tangent will have a what kind of asymptote? Horizontal asymptote at pi over 2. Tangent has a vertical asymptote at negative pi over 2. The inverse tangent will have a horizontal asymptote at negative pi over 2. Is everybody clear? So the green straight lines are the horizontal asymptotes for the inverse tangent. Am I making sense? Is everybody clear? Okay, that's one thing. The second thing is I am looking at the line y equals to x. So this is the line. This is the line y equals to x. Notice that when I drew that, I drew it as a tangent to the graph of the tangent function. Y equals to x is a tangent line to the graph of the tangent function at 0. How do I know that? Can someone tell me how do I know that the line y equals to x is the tangent line to the graph of the tangent function at 0? How do I know that? That is what I'm trying to get at, is that how do I know the graph of tangent and the y equals to x does not look like? So I know that the graph of tangent is like this, right? My question is, how do I know that the line y equals to x is not something like this, where it intersects the tangent function at more than 1 point? How do I know that? How do I know it is a tangent line to the graph of the tangent function? How do I know that? Anyone? Is my question clear to you? I have, one more time, I have this, and I'm saying, how do I know the graph of the tangent function and the graph of y equals to x? How do I know it doesn't look like what I drew in blue? Because I know that the y equals to x is going to be a tangent line. It's going to be a tangent line to the graph of the tangent function at 0. Okay, yeah. Yeah, very good. If I look at the derivative of tangent, that's secant squared, and at 0, secant squared is 1. Secant squared of 0 is 1. So I know that the slope of the tangent at 0 is exactly 1, right? If the slope is 1, it's got to be the line y equals to x. Okay? Very good. So then I know that's how it looks like. Now it's very clear what would be the graph of the inverse. The graph of the inverse would have to be the reflection of the graph of tangent across the line y equals to x, and that's the green curve. Remember what I said. The graph of tangent inverse will have a horizontal asymptote at pi over 2. It will have a horizontal asymptote at negative pi over 2. Right? Everybody's clear? What else do I know? How do I know that as x goes to infinity, tangent inverse of x is approaching pi over 2? How do I know that the tangent, as x goes to infinity, tangent inverse of x is going to pi over 2. How did I know that? How do I know that? Well, think about y to be tangent inverse of x, right? And I'm saying what happens to y as x goes to infinity. And I'm saying y goes to pi over 2 as x goes to infinity, right? Why? Well, it means that tangent of y is what? If y is tangent inverse of x, then tangent of y is x. Now, as x goes to infinity, tangent of y goes to infinity, right? But look at the tangent graph. Tangent of y goes to infinity, right? Doesn't that mean that y has to go to pi over 2? The only way tangent of y goes to infinity is when y goes to tangent. The only way tangent of an angle goes to infinity is when the angle is approaching pi over 2. Right? Is that clear? Maybe instead of y, maybe I should be using theta or something. Maybe the other y is confusing. So this is theta and this is theta. So I'm saying as x goes to infinity, tangent of theta goes to infinity, but tangent of theta goes to infinity if the angle theta goes to pi over 2. That's the only way. That's clear from the graph of tangent, right? Same way, if x goes to negative infinity, tangent of theta goes to negative infinity. If tangent of theta goes to negative infinity, that means the angle must be near negative pi over 2. Okay, so that's how I know the limit. So I know that the limit of tangent inverse. I know that the limit of tangent inverse of x as x goes to infinity is pi over 2. I know that the limit of tangent inverse of x as x goes to negative infinity is negative pi over 2. You have to memorize those two limits because they will be applied in some of the limit problems later. Is that okay? Is everybody clear? Any questions on the graph? On the graph of tangent and tangent inverse? Okay. So once again, tangent inverse of x is y if and only if tangent of y is x, because this is the tangent inverse is the inverse of the tangent function. So they do the opposite of each other, right? So if tangent inverse takes x to y, if and only if tangent takes y back to x. I have, what are the cancellation properties? What are the cancellation laws here? The cancellation. Remember, anytime you have a pair of inverses, there are two associated cancellation laws or properties. What are they? Well, take the composition of the two in any order, you get the identity function, right? So tangent of tangent inverse of x is x. Tangent inverse of tangent of x is x. In the first case, x is in the domain of tangent inverse. So in the first case, x could be any real number. In the second case, x could be any number between negative pi over 2 and positive pi over 2. So in the second case, x is an angle, right? X is an angle between negative pi over 2 and positive pi over 2. In the first case, x is any number between negative infinity and positive infinity. Okay? Any questions on the cancellation laws? Any questions at all? Okay. Now, how do I find the derivative of tangent inverse? How do I find the derivative of tangent inverse? Remember what I said, anytime I have a pair of inverses, if I know the derivative of one of them, I can find the derivative of the other one by using implicit differentiation. How? Well, you're going to set you're going to set y to be tangent inverse of x, and then you're going to say, well, it means tangent of y is x. Now you take the derivative of both sides with respect to x. What's the derivative of x with respect to x? 1. What's the derivative of tangent of y with respect to y? Secant squared of y, and am I forgetting anything? Times the y prime, or you could say dy dx. Well, this implies then y prime is what? 1 over secant squared of y. Now, at this point, I want to write my derivative in terms of x. How would I do it here? Either I can use the fact that tangent of y is x. I can use that and say that tangent is opposite over adjacent. Go back to the definition of the trig functions in terms of triangles and circle. Go back there and figure out what is secant squared of y in terms of x. I won't do it. I did that for sine, but I will do it algebraically. How? I know that secant squared of y is what? 1 plus tangent squared of y. However, what does that mean? It means I have 1 plus tangent of y whole squared. And do I know what is tangent of y? Tangent of y is x. Right here. Tangent of y is x. So I get 1 over 1 plus x squared. So finally I could say y prime is 1 over 1 plus x squared. Okay, so that means that the derivative with respect to x of 1 over 1 plus x squared. Oops, what am I saying? Okay, so this is a tangent inverse of x. It is 1 over 1 plus x squared. Okay, this is my last section that I teach, and sometimes I am a little bit tired, especially coming from my other section. Okay, this is my other section. The students are not that exciting, in fact. So, in any case, but you guys have been keeping it up. So, 1 over 1 plus x squared. So what is that? What would be the integral of 1 over 1 plus x squared? Inverse tangent. So what I want to do, I didn't do this for sine inverse. I forgot to tell you how to find the integral of sine inverse, right? But I want to tell you how to find the integral of tangent inverse now. And the way I'm doing it for tangent inverse, you do the same thing for sine inverse. Am I clear? So how would I find the integral of tangent inverse? Any suggestion? How should I start, or what method I should be trying to apply? You have learned a lot of. You have done a lot of. Someone was telling me that he's a little bit mad maybe about doing a lot of integral problems, but you have done a lot of problems in integration. How would you tackle this one? What method do you think is going to work out? What is your gut feeling? Don't think too much. What are our premier tools? U substitution or integration by parts? Do you see any type of composition or anything going on that might allow you to use U substitution? No. So that tells you what? Maybe Maybe integration by parts. Okay, so let's think about integration by parts. Now, when you do integration by parts, you have to make a choice for u. You have to make a choice for dv, right? Remember that? What choice would you make for dv, and what choice would you make for u? Very good. It is going to be totally useless to take dv to be tangent inverse of x dx. You may say, hey, I'm going to pick u to be 1 and dv to be tangent inverse of dx, right? That's a bad choice. So the choice you want to make here is that u is there isn't really a choice, because you're trying to take the integral of tangent inverse, and you know the derivative of tangent inverse, right? So you take u to be tangent inverse of x, and then dv would be the rest, which is 1 dx, right? 1 dx. Is everybody okay? And when you take the integral of sine inverse, you're going to take u to be sine inverse. If you take the integral of cosine inverse, you're going to take u to be cosine inverse. Now, what is du? Well, we just found out the derivative to be 1 over 1 plus x squared, right? So I get this. And what is v? V is x. Now, integration by parts tells you what? Integration by parts tells you uv. So let me multiply u and v. And u and v is what? X times tangent inverse of x minus v du. V du would be x times 1 over 1 plus x squared. So that's this. You agree with that? Now I have to find the integral of x over 1 plus x squared. But by now, it should be very familiar. What should I do in this case? How do I find the integral of x over? Now it's a u substitution, because if you look at the denominator, the derivative of the denominator is in the numerator, sitting in the numerator. So how do I find this integral? Let me do that in red. So I am looking into the integral of x over 1 plus x squared dx, and what I'm suggesting is take u to be 1 plus x squared, that is the denominator, and then du would be 2x dx, which tells you half du is dx. So let's make that substitution. What am I going to get here? Yeah, notice that I can combine x and dx into half du. So I get 1 over u times half du. You guys agree with that? You guys agree with that? And then I can take the half out. So this is half integral of 1 over u du. But what's the integral of 1 over u? This would be half natural log of what? Absolute value of u. Natural log of absolute value of u, right? However, then I have to write back u equals to what? So then what am I getting at the end? X tangent inverse of x, and then the integral is half ln of absolute value of u, but u is what? 1 plus x squared. However, do I need absolute values? I don't really need absolute values, because 1 plus x squared is positive, so this is this plus the c. Let's see if you agree with that. So that's how I could accomplish finding the integral of tangent inverse. Okay. You can find the integral of sine inverse, cosine inverse exactly the same way. Okay? Yeah.
Why did made u 1 plus x squared?
Yeah.
How did the integral become 1 over u? Is this measure written?
Right here?
Well, one above that, I guess.
Here?
Yeah.
So you have this integral. You are taking this denominator to be u, right?
Okay.
So the denominator is u. This whole x and dx together, I forgot to write x dx, didn't I? This should be an x here, right? So x dx together is half du. So in the denominator I got u, x dx is half du. Is that okay? Yeah. And that's how you get 1 over u. Okay, so that's the integral, and we see the derivative as well. Let's do some other exercises. What is tangent inverse of 0? Yeah. Yeah. This is okay? Right here? Yeah, go ahead. Yeah.
Do you get the same answer using integration by parts?
Integration by parts on what? This one?
Yeah.
You want to apply integration by parts to this integral?
Yeah.
And what you're gonna go back to this. You realize that?
Yeah, that's what I did. That's why I was confused.
Yeah. If you apply integration by parts on this one, I think you're gonna take u to the x, right? And you're gonna take 1 over 1 plus x squared to be dd. And then when you apply integration by parts, you're gonna end up with tangent inverse again. Okay? So yeah, so that's why you can't really do it. Okay, so okay, what is tangent? Is everyone done writing it down? What is tangent inverse of u? 0. Is 0 because tangent of 0 is 0. What is tangent inverse of 1? What is tangent inverse of 1? Huh? Pi over? Remember that pi over 2 tangent is undefined, right? This is pi over 4. Remember, tangent is sine over cosine, and at pi over 4, sine and cosine are the same. Because tangent of pi over 4 is 1. And what is tangent inverse of 1 over root 3? Very good, pi over 6. Because if I look at tangent of pi over 6, that is sine pi over 6 over cosine pi over 6. And sine pi over 6 is half. The other one is root 3 over 2. And then you end up with 1 over root 3. Alright? Next question. What is a cosine of tangent inverse of x? Now let me tell you this. If you understand every single item that we went over on sine inverse function, then you should have no trouble to go over every single item in the handout for tangent inverse. We are not doing anything much different. Okay, if you look at the two handouts, you'll see that I have the same problems for both functions. Okay, what is cosine of tangent inverse of x? That is, I am looking for an answer in terms of x only. Yes.
1 over the square root of 1 plus x squared.
Yeah, and let's see how we get there. Okay, very very good. He's very quick. All right.
Well, I worked on while you were talking.
Oh, okay. All right. All right. So how would you do this? Well, let's just look at the steps. We're going to take theta to be tangent inverse. So we know that tangent inverse of x is an angle, and the angle lies where? Theta is an angle between minus pi over 2 and pi over 2. Okay, so I also know that then tangent of theta is what? Is x, and which I'm going to think of as x divided by 1, and I'm going to think of this as opposite over adjacent, right? And okay, so the angle theta is either in the first quadrant or the fourth quadrant, right? Because it is between negative pi over 2 and positive pi over 2. For the moment, I'm going to assume that theta is a positive angle. It is in the first quadrant. So I'm assuming theta is here. In that case, what is the reference triangle? The reference triangle is here, and the opposite would be x. The adjacent would be 1. The opposite would be by Pythagoras 1 plus x squared, and I take the root of that. By Pythagoras, that's what I get. So from there, do I know what is cosine of theta? What is cosine of theta? 1 over adjacent over hypotenuse, right? 1 over root of 1 plus x squared. Is everybody clear? And cosine theta is the same as this. Remember, the tangent inverse of x is theta, right? So cosine theta is the answer. Is everybody okay? You might complain though that what if theta is in the fourth quadrant, right? And I claim that I'm going to get the same answer. In fact, it's enough to look at one of those triangles. But let's just see for the sake of it. What if theta is in the other quadrant? If theta is in the other quadrant, then let's use red for the other triangle. If theta is in the other one, then I get the red reference triangle. In that case, again, what's the opposite? The opposite is the red segment. Its value is still x. What is the adjacent? The adjacent would be 1, as before. And then what is the hypotenuse? The hypotenuse is still root of 1 plus x squared. So it doesn't matter if theta is in the fourth or the first, I still get the same value for cosine theta. Either way. Now this problem was a little bit complicated because we are not given a value for x. So x could be positive or negative. If x is positive, theta is in the first quadrant. If x is negative, theta is in the fourth quadrant. Right? However, let's say I give you a cosine of tangent inverse of 3. So x is positive. In that case, I know that the angle theta would be in the first quadrant, right? You realize that? If I give you the x value, if the x value is 3, theta I know for sure is in the first quadrant. If x value is negative 3, it's a negative number, then I know that it has to be in the fourth quadrant. Am I making sense? So again, tangent inverse of x is giving you an angle between negative pi over 2 to positive pi over 2. Tangent inverse of x is a negative angle if x is negative. It's a positive angle if x is positive. Okay? Alright, so that's the end of that. Let's look at some domain questions. What's the domain of tangent inverse of 2x plus 1? What is the domain of tangent inverse of 2x plus 1? Do I know the domain of tangent inverse of x? The domain of tangent inverse of x is all real numbers, right? The domain of tangent inverse would be all real numbers. So what's the domain of tangent inverse of 2x plus 1? Let me write that down. The domain of tangent inverse of x is all real numbers. Remember, the range of tangent is all real numbers, right? You remember the graph of tangent? It went from negative infinity to positive infinity. The range of tangent is all real numbers, so the range, the domain of tangent inverse would be this. Question is, what's the domain of tangent inverse of 2x plus 1? What question do you ask when you look into domain question? You think about what are the valid values of x, right, for which my expression makes sense. The question is, can x be any real number? In my expression, tangent inverse of 2x plus 1, does it make sense for any real value of x? That's what you want to ask. The answer is yes, because if x is any real number, what is 2x plus 1? It's just another real number. And can I apply tangent inverse to that? Yes. Tangent inverse can be applied to any real number. Right? So I can take x to be any real number, because tangent inverse can be applied to any real numbers. So the answer is the domain here, the domain is all real numbers here. All real numbers. How about if I have x squared minus 1? Instead of 2x plus 1, what if I have x squared minus 1? What's the domain here? Again, all real, because if x is any real number, then x squared minus 1 is just another real number, and you can apply tangent inverse to that. So there is no problem, so I get this. How about tangent inverse of root x, though? What's the domain now? Yeah, now x cannot be any real number. X has to be a non-negative number, because otherwise you cannot apply the root, the even root. Because of the even root, x has to be 0 or positive, right? 0 or positive. And then I'm going to get another positive number, and I can apply tangent inverse to that, so there is no problem. So that's the domain in that case. Alright, now I have a limit question. What's the limit of tangent inverse of 1 over x minus 2 as x goes to 2 from the left? As x goes to 2 from the left. Let me write it down this way. As x goes to 2 from the left, can someone tell me what is happening to the quantity within the parenthesis? This is going where? I'm sorry? What did you say? Negative infinity? Yes, it is negative infinity, right? Why? Because think about what is happening to the denominator. Think about the fact that on the real line, if I have 2 here, x is going to 2 from the left. Doesn't it mean that x is less than 2? Doesn't it mean that x minus 2 is less than 0? So what it means is that the denominator, x minus 2, is negative, right? Because x is going to 2 from the left, my denominator is negative. However, it is shrinking to 0. So think about dividing 1 by negative 0.00000000001, right? Are you going to get something big? Yes. So I know that it's negative and big. So this is negative and big. Negative and big. So I know that. So I have that quantity inside the parenthesis goes to infinity. And so what is happening to tangent inverse? Yeah. Oops. I have 1 over x minus 2. And the quantity inside parenthesis goes to negative infinity, so this guy is going to go to pi over 2. Why? Because at the very beginning I said tangent inverse of x, it goes to pi over 2 as x goes to infinity, right? So you have to remember that. Tangent inverse of a quantity that goes to infinity will go to pi over 2. Will I get a different answer instead of 2 minus if I have 2 plus? That is, if I look at the limit as x goes to 2 from the right, what would be your final answer? Hey, I said something wrong. No one is telling me what. It is negative pi over 2, right? So will my answer change if I have, what will that be? Pi over 2, okay? So I do have a mistake there. It's going to be negative pi over 2. Okay, any questions on the limit problem? What's the integral of 1 over 1 plus x squared dx? Well, we know that the derivative of tangent inverse is 1 over 1 plus x squared. So the integral of 1 over 1 plus x squared is tangent inverse plus c. My question to you is, what's the integral of 9 plus x squared? 1 over 9 plus x squared. What's the integral of 1 over 9 plus x squared? How would you do that? Well, you look at that and you compare it to the previous integral. You say that I wish 9 was 1. Okay? So now you want to come up with some sort of conspiracy to turn 9 into 1. So how do I turn 9 into 1? Well, you now think about, hey, if I had a 9 as a coefficient of x squared, I could have just factored out 9. Am I making sense? Well, how do I introduce a coefficient of 9 in front of x squared? Well, that means I want to replace x squared by 9u squared, right? I want to do that. Well, what substitution will allow me to write x squared as 9u squared? Well, that would be x equals to what? X equals to 3u will allow me to write x squared as 9u squared. And if I do that, I can factor out 9, make it look like the first integral. Notice what is dx then? 3 du. And also let me write down that u is x divided by 3. All that is good. Now let's make the substitution here. I get 1 over 9 plus x squared is 9u squared, and dx is 3 du. Right? Now I factor out the 9. If I factor out the 9, I get 9 times 1 plus u squared 3 du, which is 3 and 9, they cancel out to 1/3, and I'm going to put the 1/3 outside of the integral, so I get 1 over 1 plus u squared du. You guys are okay with that? 3 and 9, they reduce to 1/3. Take it outside of the integral, I get this. Now I could say what? Yeah, this is 1/3 tangent inverse of u, right? However, what is tangent inverse of u? What is u? That is, u is, remember I made the substitution x equals to 3u, which told me u is x over 3. So this will be x over 3 plus a c. Am I making sense? Now you realize where that 1/3 coming in antiderivative. In my final answer, you see that I have 1/3 outside of the tangent inverse. I also have 1/3 within this parenthesis here, right? Where is that 1/3 coming up from? Or where is that 3 coming from? In fact, that 3 is coming from this 9. Is the root of 9. So why am I pointing that out? Well, so at the end what we got is 1 over 9 plus x squared. If I take the integral of that, I get 1/3 tangent inverse of x over 3 plus a c, and I can generalize that to say that 1 over a squared plus x squared, where a is any fixed number. This would be 1 over a tangent inverse of x over a plus c. Do you guys remember what we got? We did the similar problem for sine inverse, right? Again, you don't have to take my word for it. All you have to do to evaluate this integral is you have to make the following substitution: x equals to au. If you make the substitution x equals to au, and evaluate your integral, you are going to come out with the right hand side, and I'm not going to go over that. Is everybody clear? So the example that we did generalizes to that. Sorry, I have to say one thing. I am assuming A is positive. I'm assuming A is positive. Is everybody okay with that? Any questions at all? Let me end by doing one more example. And this is the integral x over 9 plus x to the 4 dx. I took it from you. Okay, how would I evaluate this integral? Does anyone see what to do? X equals to what? 3 squared. Oh, x equals to a square root of u, you're saying? 3 square root of u. Yes. And why are you saying that? Because that's going to give you what? So what he's trying to say is that I have that 9 plus x to the 4. If I had 9 plus x squared and if I didn't have that x, then I know what to do. So his goal was to sort of reduce it to look like the first integral that we have seen. So the idea is that, let me write one more line to show you what he's trying to say. This is 9 plus x squared squared, right? And notice that if I pick u to be x squared, then the denominator becomes 9 plus u squared, right? Am I making sense? But instead of this, we're going to pick this because I have that 9 there. So let's make u to be... Oh, you know what? I'm not going to put 9 there. I'm just going to use my previous result to do it, okay? So I'm just going to say u equals to this. And then what is du? Just because I have done some work already, you should be doing 3x squared, but I'm saying I'm going to use the previous integral. So this is, if I do that, then I get 2x dx, and then half du is x dx. So then my integral would be x dx will become half du, and my integrand becomes 1 over 9 plus u squared, right? You agree? So then I get half integral of 1 over 9 plus u squared du, and this would be equals to 1 over half times, we know this integral is the first integral that we computed, and that was 1/3 tangent inverse of u divided by 3, and finally I get 1/6 tangent inverse, what was u again? X squared over 3 plus c. Now you should have done the substitution u equals to 3x squared if you don't want to remember that formula that I gave. Okay, but I have used it because I have done it previously. So the formula I am referring to is this one, this formula here. If you don't want to remember that, make the substitution 3x squared here. Alright, so this is the end of tangent inverse. Next time I'll be going over secant inverse, okay?